So today we're going to learn about arithmetic and geometric sequences. So a sequence is just a list of numbers in a particular order. So I gave you an example. So this first example, I gave you 3, 6, 9, and 12. So to go from 3 to 6, you can add 3. To go from 6 to 9, you're going to add 3. To go from 9 to 12, you can add 3. So this is actually an example of an arithmetic sequence, which we'll talk about in a second. So in a sequence, the first term is A1, the second term is A2, and so on. So you can have A3, A4, A5, forever and ever. Many sequences have patterns. The two types of sequences that we will be studying are arithmetic and geometric. So let's look at arithmetic sequences first. So an arithmetic sequence is a sequence where each term is found by adding a constant to the previous term. This constant is called the common difference. So example number 1. Find the common difference of 3, 6, 9, and 12. So how can we go from 3 to 6? We can add 3. How can we go from 6 to 9? We can add 3. How can we go from 9 to 12? We can add 3. Now, for an arithmetic sequence, they all have to be the same common difference. So we had to add 3 each time to get the next term. They can't be different. In this example, our common difference will be 3. This is an arithmetic sequence. Okay, let's look at the next example. So find the common difference of the following sequence: 55, 49, and 43. 55, 49, 43. How can we go from 55 to 49? We can subtract 6. How can we go from 49 to 43? We can subtract 6. So this is going to be an example of an arithmetic sequence with a common difference of -6. So let's take a detour and look at two different types of formulas. There's recursive formulas and explicit formulas. In a recursive formula, each term is found by doing something to the term that's immediately in front of that term. So it has to be the one that's directly in front of it. For example, take the arithmetic sequence 2, 4, 6, 8. Each term is found by adding what to the term before it? So to go from 2 to 4, what do we add? 4 to 6, what do we add? 6 to 8, what are we going to add? It's going to be 2, right? We're going to add 2. So a recursive formula for this sequence would be a subscript n equals a subscript n minus 1 plus 2. Let's check to make sure this recursive formula would be right. So we have 2, 4, 6, 8. That's our sequence. And if we were to label, this would be A1, 4 would be A2, 6 would be A3, 8 would be A4. So let's check to make sure that this formula will give us A2. So our formula will be A to the 2 minus 1 plus 2, which gives us A1 plus 2. And what is A1? A1 is 2. So we'll have 2 plus 2, which is 4. And is A2 4? Yes. So it worked. Now let's try A3 just to make sure we have the hang of this. So A3 would be A to the 3 minus 1 plus 2, which will give me A2 plus 2. And what is A2? A2 is 4. So we'll have 4 plus 2, which is 6. And is A3 6? Yes. Okay. So let's use this recursive formula to find a to the 6. I'm just going to copy this down again. So our recursive formula is a subscript n minus 1 plus 2. And we're using 2, 4, 6, 8. We have A1, A2, A3, and A4. So we need to find A6. So for our recursive formula, we're going to need to know the term that's directly in front of it. But do we know A5? No. The highest term that we know is A4. So that's where we've got to start. So we can use A4 to find A5. So A5 is going to be A4 plus 2. A4 is 8 plus 2, so A5 is 10. Now we can use A5 to find A6. So A6 will be A5 plus 2. A5 is 10 plus 2 gives me 12. So A6 will be 12. Now, could we use this formula to find a to the 100th? Yes. What would we need to know in order to find a to the 100th? We would need to know the term that's directly in front of it, right? Which would be a to the 99. A subscript 99. So what are some drawbacks that you can see to recursive formulas? First, they can get time consuming, because you're always going to have to know the term that's directly in front of it. So there's no skipping terms, which leads back to the time consuming problem.